Okay, this is another MCA 8th grade math lesson, and today we're going to talk about inequalities on the number line. We've seen inequalities before, except for now they're going to be used as more of equation type things, okay? So normally the equations we work with are like 2x plus 5 equals 10, okay? That type of thing, where we have an equation, we have some unknown, and it's equal to something. These are inequalities. That means they're not necessarily equal to something, and I'll show you what we're talking about. Take, for instance, a situation like this. It says Tom is thinking of a number between 1 and 10. Of what possible numbers could he be thinking? Now, what we talked about in class today is, usually when people ask us this question, they say, hey, pick a number between 1 and 10. Automatically, we typically go for those easy numbers, 2, 3, 4, 5, 6, 7, 8. The whole numbers and 9. The whole numbers between 1 and 10. But there are actually many different types of numbers between 1 and 10. Actually, there are an infinite amount of numbers between 1 and 10. So, for instance, like they say here, we could assume he's thinking of a counting number. However, he could be thinking of 2.5, or pi, or the square root of 20, because all of these numbers are also between 1 and 10. So how do we even show, or begin to even think of, all the possible numbers that could be between 1 and 10? Well, we can write an inequality to indicate the range of possible numbers. We let x represent a possible number, and we write this. This means, and I will say it as we look at it here, x is greater than 1 and less than 10. Okay, and I have that right here. X is greater than 1 and less than 10. Notice that both the description and the inequality exclude 1 and 10. Okay, so we don't have greater than or equal to or less than or equal to, which I'll show you in a second. This is just greater than and less than. So we're not including 1 and 10 because we're only talking about the numbers between 1 and 10, not 1 and 10. If that makes sense. Alright, so here's what it would look like on a number line if we were to graph it. We're looking at all the possible numbers between 1 and 10. We have open circles on 1 and an open circle on 10. Okay, so two open circles, that means we're not including 1 and 10 in our graph. If we were including them, they'd be filled in, and I'll show you what that looks like in a second. So this is the range of possible numbers between 1 and 10. Okay, so we pretty much just summed that up right here. Okay, yep, so the open circles indicate that numbers 1 and 10 are excluded from the choices. Alright, and to show if those numbers were to be included, we would make a shaded dot or we would fill them in. So for instance, this graph shows two numbers that are, one that's excluded, one that's included. If you're including the 4, you shade in. If you're excluding the 2, you do not shade in. It's an open circle. So this reads greater than 2, less than or equal to 4. Okay, so it would look like this. X is greater than 2, less than or equal to 4. So this symbol is less than or equal to. This one is just greater than. Okay, not greater than or equal to. Okay, so even with just looking at this, you should be able to tell if you're going to fill in your circle or not. If there's a line underneath your symbol, you're going to include this number. If there's not a line, you do not include, you would exclude that number. Alright, so let's take a look at some of these here. So let's think of this number scenario here, except we're going to take it one step further. Christina is thinking of a number. If she doubles the number, the product is greater than 4. Write an inequality for this description. And then we're going to graph on the number line all the possible choices for the number. Okay, so it says she's thinking of a number, and if she doubles that number, the product is greater than 4. It's not greater than or equal to 4, it's just going to be bigger than 4. So we're not going to include 4, okay? So 4 is excluded. So to set this up, we're going to say if she doubles a number, so some number, let's call that number n, and whenever she doubles it 2 times n, it is, greater than 4, sorry. It will be greater than 4 whenever she doubles it. Now the thing about these is we can treat these like equations. And notice how just greater than 4, we're not including it with the line. Okay. We have to figure out what our number could be to make this situation possible. So what we have to do is solve for n. And we can do that just like we've been solving for normal equations. Treat this like an equal sign and we solve. So how do we solve for n? We want to get it by itself. Well, 2 times n, so we want to divide by 2 so that those cancel. We have to do that over here too. So 4 divided by 2 is 2. And you're left with n. Sorry, there we go. Alright, so this would be your inequality then. This would be like your equation right here. Alright, so n is greater than 2. And let's see if that makes sense. If she doubles the number, it has to be greater than 4. So, wouldn't n have to be greater than 2 in order for the product to be bigger than 4? Yes, because if I said a number and I said 1, 2 times 1 is not greater than 4. But 2 times 2.5 is 5, which is greater than 4. So n does have to be bigger than 2 to make this possible. So here's your inequality, and now to graph that, we write a little number line. And you'll probably want to put at least 5 numbers on there. 0, 1, 2, 3, 4. You'll get good at picking out which numbers you should use. 2 is in the middle, and I know I'm going to have to go left or right here. So we're not including 2, that's an open circle on 2. And we are saying our number has to be greater than 2. So it could be anything from 2 on up, but not including 2. So we would draw a graph like that. Okay? So that's how we would show all the possible choices. Alright, let's take a look at this one. Sometimes they don't give you a scenario, they just give you an equation or an inequality. So 3x plus 1 is less than or equal to 7. We want to solve and graph. So what does x have to be to make this possible? So we have 3x plus 1. And we can't graph until we solve. And right off the bat, we should see it's less than or equal to, so when we do graph, we're going to have a shaded dot because it has the line underneath it. So, first thing we want to do, what plus 1 gets you to 7? Well, 6 plus 1 does, so we know this has to be equal to 6. But to actually show that, we would subtract the 1, be the inverse of adding 1 from both sides. So those cancel out with each other. You're left with 3x, or 3 times x, is less than or equal to 7 minus 1, which is 6. Inverse of multiplying would be dividing. Or 3 times what gets you to 6? It's 2. Alright, so we divide on both sides, and we're left with x is less than or equal to 2. Alright, so there's our solved inequality. And we want to graph this. Okay. And if you're ever unsure if you get to the right solution, you can try this. If we put in a number less than or equal to 1, we should get a number that's less than or equal to 7. So let's put in 1 for x and see what happens. 3 times 1 is 3, plus 1 is 4. 4 is less than 7, so that works. Now if we put a number that's greater than 2, for instance 3, we should get a number that's bigger than 7, because, well, that shouldn't work, right? If we put in a number bigger, it's going to make this untrue. So let's put 3 in for x, because obviously 3 is bigger than 2, so it wouldn't make sense, so that shouldn't make sense. if I put 3 in, 3 times 3 is 9, plus 1 is 10. 10 is not less than 7 or equal to it, so that wouldn't work. This solution looks okay. Alright? So, and of course if you did put 2 in, you'd get 3 times 2 is 6, plus 1 is 7. So obviously this works out very nicely. 2 is less than or equal to, or x is less than or equal to 2. Alright, so that's like your point.
Can I have your attention for a few quick announcements? Just a reminder to 7th and 8th grade girls that are participating in softball. Optional practice today. You'll meet on the junior high field on the south side of the school. Remember, it's an optional practice today, tomorrow, and Thursday. Also, a reminder that there's a baseball meeting for 7th and 8th grade boys after school tomorrow. And on Monday, golf will start. You'll have a meeting at the clubhouse after school, so plan on attending. 7th and 8th graders are planning on being out for golf meeting on Monday. Thank you.
Alright, sorry about that. So the only thing that's different here is that we have a graph that x, or whatever our number is, has to be less than or equal to 2. And so we have the less than or equal to symbol, and we're going to fill in the circle this time, because we're including 2 and it's everything less than 2. That would make that statement true. Okay? Let's do one more, and then we'll be done. Okay, this is a good one, kind of a real life application here. Vincent goes to the store with $20 to buy a notebook for $4. He notices that packages of notebook paper are on sale for $2. Write and solve an inequality to show the number of packages of notebook paper he could buy if he also buys the notebook. So he's going to buy the notebook, and then he's going to see how many packages of notebook paper he could buy for $2. So we've got $20 to work with here. So obviously whatever he spends has to be less than or equal to $20. Okay? Because you don't have more than that. So no matter what, he's going to buy a notebook for $4. And he's going to add on $2 for every package that he buys of this notebook paper. So 2 times however many packages of paper he buys. So there's our equation. Now let's solve for P, and that should tell us how many packages he can buy. Okay, so we subtract 4 from both sides. 2 times P is, that comes down, and 20 minus 4 is 16. Okay, now if we solve for P, we divide it by 2. And we get P is less than or equal to 8. Okay, so he could buy 8 packages of notebook paper and a $4 notebook, and that would get him to $20 even, so we're ignoring the sales tax there. Alright, now if we want to show the graph of this, it's going to be a little bit different because let's look at it. We're looking at packages that he could buy of paper. So we're going to go 0, 1, 2, 3, 4, and make this bigger, 5, 6, 7, oops, and 8. Going up by 2s just to save room. Alright, he could buy, it's not saying he's going to buy 8 packages of paper. He could buy anywhere from 0 to 8. All we know is that he is going to buy a notebook. Okay, so he could get 0 packages. He could get 1, he could get 2, 3, 4, 5, 6, 7, or 8. The reason we're not going to do any lines or fill in and shade in between each number is because you can't buy a fraction of the paper or the package. You can't get half of a package or 2.3 things, 2.3 3 packages, you're only going to buy whole numbers of that package. So that's why the graph looks like that for this one. But that would be the answer to this one right here. All right. We'll work with this more a little bit later.